Okay, in this problem we're given a function f of x is equal to the cubed root of x minus the tangent of 2x all over the cosine of 3x. And we're asked in this problem to find the derivative of the function. So let's go ahead and begin the derivative using our little ditty here, low d high minus high d low all over low low. So we're going to do this the nice and slow way so that we don't make mistakes. This is the low, so I'm going to make my quotient bar here rather long. So I take the bottom function, cosine of 3x, and all I do is I write d dx of the high function. This is d high. So I'm going to write the cubed root of x as x to the 1/3 so that I can use the power rule more easily, minus tangent of 2x, okay, minus high, which is x to the 1/3, minus tangent of 2x, times d low, so this is d dx of the cosine of 3x. There we go. All over low low, so I'll put this as cosine squared of 3x. What I do next is I do this in pieces. So what I'm going to do is I'm going to do this piece. What is the derivative with respect to x of x to the 1/3 minus the tangent of 2x? Okay, so I use the power rule. This becomes 1/3 x to the negative 2/3, and then minus the derivative of tangent is secant squared, but then by the chain rule I differentiate 2x and I get 2, so this becomes minus 2 secant squared of 2x. And that's this piece right here. Now I'm going to do this piece, d dx of the cosine of 3x. And so the derivative of cosine is negative sine. By the chain rule, the derivative of 3x is 3, so I get negative 3 sine of 3x. Now what I do is I insert these pieces back into the difference quotient. So f prime of x equals, and I'm going to write a large quotient here, give myself plenty of space, cosine of 3x times this 1/3 x to the negative 2/3 minus 2 secant squared of 2x, and then minus x to the 1/3 minus tangent of 2x times negative 3 sine of 3x all over cosine squared of 3x. Now I know that the derivative here is correct because I've done it in pieces. And so this is how I encourage you to do your derivatives, in pieces. Break them up, work on them part by part, and then reassemble them, put them back together again. Now I'm also going to do that same method by trying to simplify here. For all intended purposes, I am done. I've completed the basic idea here. I've got the derivative of the function. Let's go ahead and let's distribute this separately. So I'm going to write the cosine of 3x times 1/3 x to the negative 2/3 minus 2 secant squared of 2x, and I'm going to distribute the cosine, so this becomes cosine of 3x. The 1/3 comes out front, x to the negative 2/3 minus 2 cosine of 3x secant squared of 2x. So that's now distributed. For this part here, I've got a negative 3 here, and I've got a negative sign in the front. So what I'm going to do is I'm just going to take this part right here, and I'm going to go ahead and I'm going to distribute this separately. go ahead and write x to the 1/3 minus tangent of 2x times -3 sine of 3x. And let's go ahead and distribute this. So this becomes -3 sine of 3x, and I've got an x to the 1/3, so what I'll do is I'll put that in front. And I'll say -3 x to the 1/3 minus plus negative times a negative is a positive. So this becomes 3 sine of 3x times the tangent of 2x. And so by treating things in pieces, I'm able to algebraically go a little bit slower. Obviously, this is still a long process, but I get to go a little bit slower, and that guarantees me that each step along the way is okay. So now what I can do is I can substitute this piece right here with all of this, and I can substitute this piece here with all of that. Remember now there's a minus here, so that will change the signs here and here. Okay? So that's how we take the derivative of this particular function.